welcome back. Now, before we get started and go deep into discussion on weak acids and bases, let's actually understand why an acid is actually strong or weak, or why should a base be strong or weak. Who gets to make those decisions? Do I get to make that decision? Like, okay, I don't like the look of it, so you got to be weak. Okay, I think you're tall. Okay, you're strong. Do I get to make that decision, or people that make those decisions, how did they make those decisions? Well, for the purpose of this class, without getting digressed too far off from the topic, it's not quite straightforward. All right, so that's the question. Why are some acids weak and some are strong? Well, I have given you a list of 6 strong acids, right? And I told you anything that's not on that list is weak. Well, that statement is true, and I'm going to stay with that. Similarly, I gave you a list of some bases, and I told you that group 1 and group 2 bases are typically strong. The rest of them are weak, and that's also a true statement. But how do I get to make that call? Well, there are 2 foundational reasons, one of them which we may not go in depth right now because I want to reserve it for when we get to electrochemistry, because this concept of oxidation number comes there, and I don't want to repeat myself in 2 places, and I think this would make more sense there, and then you can relate it back to why some are strong, why some are weak. As I said, the answer is not as straightforward, like, one size fits all kind of deal. And the second thing is electronegativity difference. Oh, you all love it, right? I mean, I think that's probably maybe 1 or 2 people that got this particular concept wrong on Chem 170 final. Most of you did do extremely well. Although some of you have a nightmare about the next thing I was going to say. So these are the 2 things that kind of, in a way, determine whether a base is strong or weak, or an acid is strong or weak. All right. So I've given you 4 acids here, and I ask you which of the following is the strongest and which one is the weakest. Now, you can just use your memory and said, well, you know what, these 3 were in your list of 6 strong acids. So definitely neither of these 3 are the weakest. I'm asking for weakest, right? So this is the weakest. So HF is weakest because it's not on the list at all. But then I could make a multiple choice straight out of this, and you might get it wrong. Because you don't know, because I have not taught you, why or which one of these 3 is the strongest. Now, if you remember from probably the 2nd or 3rd week of Chem 170, I know it's really, really long time ago, centuries ago, so you probably may not remember this, but there's 2 ways to do this. I'll give you both. Electronegativity, right, increases as you went from left to right, and it decreases as you went from top to bottom on the periodic table, right? Now, if you remember, well, fluorine, chlorine, bromine, iodine, which are all found in all 4 of these acids, in each one of the acids. Now, fluorine, if you go by this definition right here, fluorine would have the highest electronegativity, and iodine would have the lowest electronegativity, right? Now, the acid is strong or weak is inverse of this relationship, okay? So higher the electronegativity, the weaker the acid, because the hydrogen cannot come off easily, see? So this is one way to do it, but you are also familiar with this table, right? If you take the difference between hydrogen and fluorine, it's about what, 1.9? Yeah, 1.9. So HF is 1.9. and HCl is 0.9, right? HBr is 0.7, and HI is 0.4. So this is same as this, okay? You can either use the electronegativity idea or electronegativity difference. The higher the electronegativity, okay, higher the En, which is electronegativity or electronegativity difference, or electronegativity difference, weaker the acid. But these three are all strong, okay? But among them, this is the weakest, second weakest, and then this is strongest. So the idea here is when your electronegativity is high, say for instance, you have HF and HI, right? They're on the opposite end of the spectrum. This has a low electronegativity compared to fluorine, right? Which is high electronegativity, right? Think about this. This is 4.0, this is 2.5, right? So the hydrogen is retained by the fluorine more strongly, okay? This attraction between hydrogen and fluorine is very strong, okay? Compared to this hydrogen and iodine interaction, which is very weak, okay? So when the attraction is very strong between hydrogen and fluorine, the hydrogen cannot come off easily, whereas when the attraction is weak, the hydrogen can come off easily. What does this mean is, if hydrogen can get out of a molecule easily, that means it is a strong acid. If it has, if its inability to leave the molecule becomes higher and higher, that is, if the interaction is strong, the fluorine is going to hold the hydrogen for a lot longer and doesn't want to let go of it, which makes it a weak acid. So what is really the order? All right, so HI is the strongest acid, followed by HBr, followed by HCl, followed by HI. So this is the strongest acid, and this is the weakest acid. Does that make sense? Because I want you to understand the science behind why some acids are strong, some are weak. Now, the electronegativity difference only helps when your acid is like bimolecular. But say we have something like H2SO4, well, that's where your oxidation number comes in, and I really don't want to get into it at this point of time. However, I do want you to know the reason on why some things are strong, some things are weak, has to do with these two. There may be other reasons too, but foundationally these two would explain the reason in greater detail. So the take-home message from this is this. Okay, as your electronegativity difference decreases, the acid becomes strong, or if electronegativity becomes higher, the acid becomes weak. Higher the electronegativity or electronegativity difference, weaker the acid. Okay. All right, and this is kind of like an introductory video to get the idea started on, this is this fine line. You can see that you got the strong acids and the weak acid. Starting now, we're going to slowly move into the world of weak acids and bases. However, I think I do have a couple of problems, like I said, to determine how to calculate pH and pOH for strong acids and strong bases as well. All right, so I'll see you back with another video. Stay tuned.